All right, welcome back from the break, everyone. We have two amazing speakers coming up that I am lucky to call not only colleagues, previous coworkers, and friends, but they are fantastic. I have fantastic memories with both of them. And without further ado, I introduce you Jessica Hyde and Aaron Sparling.
Hi, everyone, and what a good, perfect word for you to say there as we start our talk about making memories, using memory analysis for faster response to user investigations. And if you just jumped over for track one, that was a different memory talk. We're going to focus really on user investigations. We know that many of you know how to use memory and IR in investigations, and we really want to stress the value in end user investigations and give you a methodology and things you can do by the end that you can take with you. So what do you think of for user investigations? There's a slew of them. These are probably what comes to your mind, everything from child sexual abuse to any of the traffickings, human drugs, weapons, money laundering, fraud, ID theft. And so we're really talking to those types of cases, but let's say you're an incident responder, you may still be doing end user type investigations, because if you're in corporate or consultancy, you may still have responsibility for IP theft, insider training, wrongful termination, workplace harassment, and all of those cases where it's not just about an intrusion. It may be about somebody inside doing something on the end user. So really the question is, why is memory forensics so critical to end user investigations? And then we're going to walk through a case of how to use it. And we promise the cool thing we're going to do is we're going to give you all of the command line arguments. We're going to give you multiple ways to do things with multiple tools. And we're going to end with giving you a useful guide that you can use in your investigations. And why is this important? Because there's artifacts everywhere, right? Everything from network artifacts and URLs that you may be used to getting from on disk, but to things that you can't find on disk, like encryption keys and passwords in some instances. And you're still going to get a lot of artifacts that you're used to seeing, like prefetch and link files. You can also carve for things like videos and pictures, get your Google searches, internet history, all of that resides in memory. And the reason that we want to get those things from memory instead of just disk is for several reasons. A, the data in memory is recent and relevant. You can do this with minimal hardware. You can use this more efficiently. As memory increases in size, so does computers. And computers, sometimes it's just too much time to actually image and look at the computer. If you need actionable intel, things that you can use today, information that can inform the investigation right now as it's happening, information that can be used to drive questioning, you can find that in memory in less time. It's going to be faster to image. And what's more important is you can actually already be working on your analysis of memory, getting great artifacts of attribution and execution while the image is still being created of the disk.
And I think there's a couple really important points on that slide, Jess, that is not only the memory as memory grows, or the consumer laptops start to see, excess of 8 and 16 gigs of physical memory, you're starting to see less being written to the page file and more reside in physical memory. So there's a high likelihood that some of your artifacts or some of your evidence may not even be written to the file system.
And a really good parallel, a really good parallel for that is for those of you who are doing mobile forensics and you're seeing data not being stored on the device anymore and only being stored in cloud. Likewise, things aren't being written to the page and they're only being written to active memory. So really good, valid point. You might not even have this evidence if you have the disk. So that really brings us to that actionable intel that can drive your investigation questions. And when you're talking about time, look at this. This is a sample that Aaron ran, and where it took 49 minutes to do the imaging of the hard drive, the physical memory plus a page file was acquired in just 8 minutes. And that is really rapid. That means in 8 minutes, you can start running some of these items. Basically, the analysis we're going to walk you through, you could do inside the time of this presentation in real time.
And that's what these numbers are based off of. So this is based off of the arbitrary case that we're going to walk you through during this presentation. And some of the things to be noted, I know people like to look at numbers and they get excited about numbers, but one other thing to take into consideration is that 8 minutes that the physical memory was acquired was over USB 2. So those times are even faster now. And if you just forego even getting the page file, which I don't recommend, but if you were to forego getting the page file, you could have access to this data in around 3 minutes. So speed is paramount and important.
So we're gonna not really talk about how you collect RAM, but we're going to assume that you're already at the point where you've gotten RAM for the purpose of this talk. We could do another whole talk about RAM analysis, and we're actually planning. We originally actually wrote a talk that covered RAM acquisition, analysis for user, and for IR. So we're probably going to have 2 more talks because we cut down to just be this talk when we drafted our material. So we're going to walk through a case. And what is the case? It's the moneymaker case. And the tasking that you have is to investigate an individual who's suspected of identity theft and credit card fraud. So this is really an investigation case type that can go for either a corporate examiner or a law enforcement examiner. And we want to give something mutual that has an end user. So let's dig into it. So what we have,
but as we go through this, taking that statement and put that into context as though, what would you look for if you were given like an EO1 of the file system, and how you can kind of wrap your head around how we would look for those same evidence of execution or artifacts of evidence within the memory acquisition.
And we're going to walk you through exactly how this worked. So in this scenario, we have an EO1 of a Dell laptop computer. We have a memory dump that was taken on location. We have a forensic image, a USB flash drive. And I do have to tell you that when Aaron made the evidence and sent it to me for the analysis, he actually did put it in evidence tape and with a chain of custody log because he thinks he's funny. We obviously couldn't meet in person to work on this right now. So in this task, and I love Aaron for it, what we have to do is we're going to analyze the raw memory dump, and we're going to get the user's activities, uncover data, locate passwords, decrypt encrypted volumes. We're going to do that all. So let's do it. And this is a little bit different than the traditional approach. We want people to be thinking differently about, usually on user investigations, and there are labs that are using memory, but typically the digital evidence item is connected at the scene and it's delivered to the lab, and the analysis is done at the lab. Disk imaging is done in that controlled environment. The image is processed and the contents are analyzed. And what we're challenging you to do is to think differently, capture the processes that are running, capture the RAM, and then analyze while you're still imaging the disk, inform the investigation. So if 8 minutes is too long, and you may go, Jessica, how can 8 minutes be too long? If you are in a scenario where you walk up into a scene and somebody is actively doing something they shouldn't be doing, this could be in an office, this could be on a search warrant. And at that moment, the person is being consensual. At any moment, they can revoke consent, depending on the situation. In a corporate setting, it might not be their system, and that might not be the case. But if you are working in a situation where consent can be revoked, I strongly advocate for using something like a process capturing tool, either a script or the free tool mentioned there, because you can get acquisition in about 20 seconds. And that is quicker than someone can say, I revoke consent. It is so super quick, and it's still a great data source. It's going to be smaller, and it's only going to be your active processes. But if you had something up on screen that was running and that's why you're there, this can be absolutely beneficial, and it might be your only source that you can have that quickly before you get other mediums in order to obtain more. And really the goal of why you want information so quickly, it goes to a couple of things. You want to be able to inform the interviewer or the interrogation, depending on your environment. Hopefully it's interviewing and not interrogating. But and you can do this through artifacts that give you user attribution. There are timelineable artifacts. There are passwords. And you can alleviate a lot of the not my pants situations up front. You know, when the nefarious actor turns around and goes, not my computer. Well, no, we can now see, and we're going to show you that this was definitively your login that was being used to touch this Tor site. So we'll go ahead and show that. And when there's encryption utilized, capturing RAM is going to be your best defense at being able to crack the encrypted devices. And we're going to show you that as well, especially when it leads to external devices. So
And
let's
that's
kick
really
it in.
important when it comes to the external devices as well, because sometimes in these cases, you're not just also given like a single device. You might be given like that shopping cart scenario, and inside that shopping cart, there's multiple external devices. And so we're also going to show you how you can rapidly triage or prioritize those devices for analysis during your investigation. And you can do that
Absolutely.
through the analysis of memory before you even get to the file system on disk.
And that's incredible, right? Because we're going to see right now how we know which device is important. So let's start by just digging into the registry. And if you didn't realize that you can do your registry analysis in memory, now you know you can. And we're going to show you a lot of tools. And I just want to be clear that we're going to show you both tools. Sometimes we'll show you two ways to do things. And we'll start off with this, with the Hive list. Some people may be familiar with volatility. And in volatility, you're going to run your Hive list command, and that's going to show you all your hives. However, I want to point out that there's a way to do this even if you don't know all your volatility commands by heart and you want to be rapid. There's actually a tool called memproc-fs, and what it does is it mounts memory and makes it viewable as a file system. Incredible. So make a working copy of your memory, run memproc-fs.exe, and now you're going to be able to see your memory as a partition. And you can go ahead and look at that. And when you look here in the mounted memory, you're going to see different folders and files. And you can see right off you've got a registry file, and you just go to that registry folder, and there is going to be all your hives. What's really cool about this is within 2 seconds, without running anything, I can instantly see all of my different SIDs. So I'm already getting to know that there's a user 2019 and 21 on this system. So I probably have different user profiles I'm going to be looking at, and I've got ntuser.dat for them. So I'm going to be able to do some cool stuff here.
One of the things that are also really exciting and unique with using this tool is folks that might be new to memory forensics and that aren't well versed with using the terminal or working in a command line. This is just using Windows Explorer. So you can navigate to these registry hives just as you would with the registry hives, similar to how you would in, say, like a third-party tool if you were to export the hives. But the other thing that's great about it is it doesn't require you to know the profile of the system for the Windows memory image.
Which credit
so
that
this like for some of those Windows 10 images that can be a little pesky, this will still, in my testing, will still mount those memory images.
And then KDBG info, running that sometimes can be clunky. Great thing about Volatility 3 is it's not supposed to be there, and you should be able, you'll be able to just access. But that's coming in the future. But today also, this is again good for people who are getting their first foothold in memory, because maybe you've been doing end user investigations and you haven't touched memory. Well, you want to know what those names are associated with those accounts. All you need to do is navigate to the path here, and you're going to see those accounts. And again, we're releasing a cheat sheet at the end with this entire workflow with both the tooling showed in volatility as well as the file system, memory proc file system, and we'll go through that. So we can see now that we've got Gymnasium, we've got Sally Butterfield. So we're starting to see things. We can see who we have. Oops. I went a little too quick, sorry. So the next thing we're going to do is we're going to figure out the control set, the current control set. And this is a simple command volatility to print key-k current control set. And we can see we're control set 001. And so we're going to then go ahead to control set 001's USB store to get some USB devices. I want to be really, really clear that not all devices are located in the enum USB store, but we're getting serial numbers very quickly here. Now, you can also navigate to this with the process file system as well. So memproc-fs will allow you to navigate here. Just two ways you can do this very quickly.
And again, what's really nice about doing this on the beginning steps of your user investigation is it might help you again to identify external devices that have brought into the lab that you want to triage, or maybe if you're on scene and you're doing a case that's on scene, and you have not yet recovered that particular device, you might want to start looking a little more closely for, say, one of those devices that might not be laid out in front of you.
So now we've seen what's in the registry. So now next thing we're going to do is we're going to dump the registry. And once we have the registry dumped, we can actually bring the system, the software, the the NTuser.dat and the Amcache hives all into USB Detective. And what I love about USB Detective is USB Detective doesn't just look at the NTuser.dat, but it pulls serial numbers and USB device information from all those places and gives us a lot of information very quickly. So here in USB Detective, we see this. We see that there was an E drive attached that was running tails. Alarm bells are now going off. And what's even better is we have the serial number. So let's say we know that we've recovered one USB drive. We don't even know if this yet is the same USB drive or if we need another, but we at least know that the USB drive with this serial number is definitively of interest, because why else would you be running an offline, a file system, an operating system on a thumb drive, right? So that tails is a big, big clue. And now we're talking registry, right? So we can take that registry from memory and we can directly jump right into RegRipper. So we can take that NTuser that we just dumped, that NTuser.dat file, and we can dump them, remember we have more than one, into RegRipper and run the NTuser profile. And that's going to help us get some really great artifacts. So just looking quickly at the user assist, what we're seeing is that Gymnasium, this is really the important part. It's not so much of Veracrypt's there. We had multiple logins. We now know that the Veracrypt executable was associated with Gymnasium login. So maybe we have some Veracrypt here. And we also see some use of the Firefox browser. So this is going to inform some other things I'm going to want to search. I'm going to want to go ahead and try to look at internet history in a bit. And now I'm going to be on the lookout for Veracrypt.
And two things to kind of comment on registry before we move on is you saw two different use case scenarios. You saw one where we dumped all of the registry hives. So we ran the hive list to see what hives were available to us in memory. And then you saw when we went after the NTuser.dat hive, we used a more targeted approach. So
yes,
you can be very granular if you want. So in that particular instance, using the hive list plugin, we were able to get the virtual offset of where the NTuser.dat hive is in memory, and then use the registry dump plugin with giving it its virtual offset to just target the user's NTuser.dat hive, which then again speeds up the process even that much more.
And then we can look at things even like recent docs. And this is going to be really cool, because when we start looking at the recent docs that we've now gotten from the Hive, we're getting the MRU list. And I always credit the fact that this is done well in this tool. If this is unfamiliar to you, 4500 really explains to you how the ordering is done in the MRU list. And what is done well is that the artifacts are actually put in order instead of numerical order by the index here, so by the key. So this is very useful, but we can see credit card stat.dex, stolen credit card copy, carding stuff, image info, license keys. Okay, I'm interested, the goods. And we can see where that path was, that these are in the recent docs. So we know that these have been accessed recently, and these are going to be things we're going to want to look at. All right, so we've kind of looked at registry really quickly. What about the MFT? And this is something people don't think about. The MFT is available in memory, and there's so much great data in the MFT. So Volatility has a really simple command for MFT parser, and I will be really clear, something I advocate for, and Aaron knows this I beat up, is I'm really, really big on output files when you're doing things on the command line. So if you can, instead of just viewing things live, pipe it out, you're going to have that for reference later. And you're also going to have, if you're taking contemporaneous notes and you're building your case based on your investigation, you're going to actually have those files created so that you can reference them later and use them in your analysis later instead of just remembering. And you could also then utilize these tools in automation. It just gives you much more flexibility, and you can parse and grep things later. So quick note on that, and thank you to all the developers who I bother about allowing their tools to give outputs. Thank you, Ryan Benson and Alexis Brignoni. Not necessarily for memory, but please, if you're writing tools, include that so people can use it.
And I think if you could go back to that slide.
Oh, sorry.
Quick,
yeah.
We highlighted just for fun in yellow that scanning the MFT and building directories can take a while. And I did that because it's kind of laughable, because I think on the file system, we're used to things taking a long time. And when we think of a long time, it's like go home and come back the next day. And so it's all relevant. With memory, when something says it takes a long time, if you're used to working in the file system, it seems lightning fast. So note that even though it says this can take a while, it's actually quite quick in comparison to working in the file system.
This is go grab your cup of coffee, not go home and come back tomorrow.
Correct.
And that's a really good point. Memory, again, this is all quick, and all of this analysis, again, can be done in the time of this talk. So we're going to grep the MFT for password, and really, really simple. You're going to find some passwords in here, actually even some that Aaron had to obfuscate here because they were keys for running tools. But what's really interesting is, don't forget, MFT can have resonant files. And sometimes things like notes, like in this instance, is what's there. So we see a notes needs to get MSR 605 for cloning card, need to get dumps for dark web. So really interesting stuff there. And that resonant data, you know, saving out that file, now you have that information and you don't even have disk yet.
And so there's two ways that you can look at that information, which is kind of nice. So as volatility goes through and it dumps those sections that are resonant, so it dumps the resonant sections of the MFT, and then it also writes it to a text file. So in that previous screen, if you weren't seeing how we were actually analyzing those dumps, we had to identify a dump that we found of interest by grepping for a particular string, and then using XXD from the command line to just quickly search those strings. And that has how we were able to granularly then drill into that particular MFT entry.
And what's really good about this too is that you're not only going to get those resonant data files, you're also going to get for other files your $ standard information and your $ file name. So you're going to get all of those MAC times so that you can really understand the creation, movement, etc. of that file. So let's get into those user artifacts. We already know there's some things we're looking for. We saw that use of Firefox. So let's see what we find here. So going into user artifacts, the first place that I usually start is looking at PS list, because that's going to show me all of the processes and executables. And if I look here, I start to see more that are of interest. We've got sticky note, which, okay, we definitely want to take a look at what notes somebody is running, but we've got TrueCrypt, we've got Tor, we've got VeriCrypt. So we've got a GPG agent, we've got lots of instances of Cleopatra. So we're going to go ahead and know that these are the areas now that we want to look at these specific executables. So PS list you use to go, which executables do I want to look at?
And I think one of the things that is important also about PS list is it's probably one of the most underwhelming plugins within the volatility framework, but it's also the one that most people learn to use first because it looks a lot like Task Explorer, so they can wrap their head around it. But not only I look at it when I'm doing a user investigation, when I'm doing memory, is to profile the user and get an idea of what is normal for them or what is running on the box during the time of acquisition. Because a lot of times I'm not the lead investigator on the case. I'm just doing the forensic analysis. So it allows me to profile the user by looking at what applications they were running. And it gives me an idea of kind of like what was going on during that particular time.
And to tie back, if you had done a process dump before you started your memory dump, that when I said that takes under 20 seconds, this is what you'd be getting. You'd be getting these running processes. So this is why we actually chose not to show it twice, but you would be exploring these running processes. And when we look at the actual mounted version of this using memproc FS, which is such a cool tool, you're going to see the same when you go just to the name directory. You're going to see all of those processes, and you've got the process name along with the PID or the process ID. So that's really super useful. But what's even cooler is if you go to the SYNFO proc tree verbose folder, you are actually going to see all of the paths and location information associated with those processes and PIDs. Which is super important because there's always those one-off cases where maybe they launched the application from an external drive, and so it might not actually have been executed on the system itself. So one of the points that we try to drive home during this presentation is by doing the memory forensic analysis, you're going to find indicators or artifacts that may have never even been on the file system. And that's really, really critical because these can be artifacts. Not only are we doing this because we can get information first, we're doing this because we may get information that we would never otherwise get. If you are not collecting memory on your end user investigations, you may be missing pivotal information. What we are about to explore and do in this case, you would not know or have access to if you only did disk. So we're going to go into the process analysis and actually look now at that, because we found some executables that we're interested in. So what we want to do is we want to dig into the actual handles, the file handles from those executables. And this is actually really easy in memproc FS and is really comfortable to people because it's just like using a file explorer. You're going to go to the one of interest, in this instance, stickynote.exe, and you're going to go files handles. And here we are seeing a slew of interesting information. We've got some passwords for Gmail, Bitcoin wallet. We've got Veracrypt passwords, so crazy interesting.
And again, on that last screenshot, what I'd really like to drive home about this is using the memproc FS and being able to get access to file objects to that particular process can be a little overwhelming for folks at first when they're first using volatility, because you would either have to scan for those kernel file objects in memory using file scan and then use dump files to actually go and pull those out, or you would have to use something like the handles plugin and then actually invoke that with the -T and then capital F for files, and then look for what file handles are associated to that particular process by PID as well. But what's nice about this is you can see that we actually have a file object for a .snt file.
Yes.
Shout out to Alyssa Torres because she loves her sticky note.exe. And in this case, we can actually interrogate this particular SNT file by just opening it up in something as WordPad or Notepad.exe.
Right. Notepad++, yeah.
Or Notepad++, thanks. And not having to actually carve it and export it and analyze it that way. So we're doing it just by directly mounting it to the file system.
And again, super accessible. Like memproc FS is like one of my new favorite tools for accessibility and teaching of memory. Because yes, you're not getting maybe as thorough of an understanding and working on the command line and understanding how the handles work, but you can get there and you can get there quick. And that's the name of the game in some instances. So we're going to investigate some other processes. We can look at the Tor executable that we were talking about. And in there, we can actually go to the user directory and see the SID of the user. Now, this is phenomenal because now we can actually say who was logged in utilizing Tor. Right? We know this was a running process. We now have the SID associated. We know the SIDs because we investigated this when we did our registry analysis. And it actually also validates and correlates the gymnasium is the 21 user who this is associated with, this activity. So Jim looks like he might be somebody who maybe at this point you want to talk to. Maybe this was Sally's system and you thought you just needed to talk to Sally, but now you know that Sally actually isn't who you need to talk to. You need to talk to Jim. Gymnasium, great naming there. So we also saw some Firefox history early on. So we want to go ahead and look at that history. So in volatility, this is pretty simple. You can go to Firefox history and then port it out to a text file. And we can see what the Chrome search terms were as well by running Chrome search terms. For the record, just a quick note, Aaron makes his life easier and actually is doing this from a directory so he doesn't have to call the plugins. In the sheet we give you at the end of this, we have all the plugin paths listed as well to help you guide your analysis there. And so I'm just going to speed up a little bit here to get some cool things. So we can also use FS to go ahead and navigate to the netstats and actually get those IP addresses for the Tor. And then we can use prefetch to go ahead and look at the other executables. And I want to get to this most important part, which is the password cracking, getting the access user credentials, because we saw that Veracrypt. So first, let's talk about NTLM hashes. Go ahead and do a hash dump. That's going to get you the NTLMs for each user. And once you have those, you can use something like CrackStation. There are other utilities you can utilize to go ahead and get the password. And we can see password 1 here. But there are other things we need to do. So for example, we can use hash dump along with bulk extractor. Shout out to Simpson Garfinkel because I believe he just announced that there's a bulk extractor 3.0 coming soon. So that'll be really cool. I can't wait to see what it does. And wordless together. And when we do that, whoop, I'm scrolling too quick. We're going to go ahead and with the word list together, run the
we utilize hashcat.
We used hashcat here. Oh, okay. We used hashcat with the word list. And then we're going to get to the password here where we have the ghost user and password 2 as the 2 passwords for these. We were able to crack them with hashcat. Hashcat's phenomenal. So this is how we can get to these.
The takeaway from that is we use 3 separate open source tools to basically get the user's login credentials. And you might ask yourself, well, why is that important, or why does that seem exciting? We all know that password reuse is actually a real thing. Most people try to pretend that they don't use the same passwords over and over again, but I'm assuming we're all pretty much guilty of that. And in this case, so we find that if we can get the user's login credentials, we might be able to attack other encrypted volumes. And so in this case, by using bulk extractor, one of the things that you can do to also speed it up is you can turn on just the word list carver with the -E and say, hey, just generate a unique word list from memory, and then take those NTLM hashes that we dumped using volatility, write that out to a text file. You have to reduce it down just to the LM hash, and then point hashcat at the split word list, or first at the NTLM hashes, and then at the split word list, and it'll crack those passwords in like a matter of like half a second. It's amazing. And that's on a laptop, on a low powered laptop. So you don't need a high end GPU cluster to attack these passwords. So that's a huge, and I think a really valuable takeaway that you can still do right there on scene, on location.
And as far as utilizing passwords for password reuse, John the Ripper does allow you to do mutations, because some people do use the same passwords, but they mutate them, adding a number to the end, etc. So John the Ripper, great tool for mutations. So then we're going to mount the image. And when we first go, so this we're now moving to the USB. Right, we've looked at some passwords, we've got some password potential. So let's go ahead and mount the USB that we have. That's our other piece of evidence. When we go ahead and try to mount the USB, we can see that it's an unrecognizable file system. So we're probably dealing with some kind of encryption. And that's where this custom VeriCrypt plugin came in that Patrick made. Aaron, if you want to talk about this quickly.
Yeah, so super quick. So Patrick is a former student of mine that I had in a class, and he basically took an existing volatility plugin and bent it to his will to solve the challenge. And he has since updated it and put it on his GitHub, and we'll have a link to that will attack. Basically, it works similar to the TrueCrypt plugin, but it's for VeriCrypt.
And so that's in the that's in the workflow guide we're going to give you. And so now we have
the password.
To that
last screenshot
yep, please.
Real quick? So there's a couple things that are really important, I think, in this is not only does this give us a potential password at the cash-money-$, which we saw previously in the memproc FS when we interrogated the sticky note file object. But also one of the things I failed to highlight is one of the file objects that's like the 4th file object down is the goods.xlsx, which we saw in the MRU list.
Yes.
So now we're starting to tie all of these different pieces of evidence and artifacts together. So holistically, in just a matter of minutes, we're able to start tying a bunch of different artifacts together and start narrowing down the focus of our investigation.
So now we actually have that disk mounted because we've now mounted it with it. And now we can start looking on the disk. And what do you know? We found it. There is all of these documents. Remember the eDrive references to the credit card, stolen credit card copies, the goods, etc. And so this is the evidence we're looking for. So if you want to go ahead.
One really important thing is that's all fake PII. So
yes, 100%. This is not this is not real. In real life, check the Loon algorithms, see if they're real. Yes. But this is all fake data. No real PII.
Since we have just a couple more minutes, one thing that I would like to just sort of piggyback on this particular process and walkthrough that we were unable to put into the slide deck due to time. If you go back to when Jessica was talking about just dumping process memory, if you were to see that VeriCrypt was running on the system and you dumped just the VeriCrypt's process memory, you could use a strings tool to run strings against that memory dump to create a unique text file, write that out to a text file. So you'd have basically your own dictionary of all the strings in the VeriCrypt process. And then you could use that text file in something like John the Ripper to potentially get even quicker access to passwords for that encrypted volume. Because if I were to show it, the password would actually be in the memory dump of VeriCrypt. You'd be able to find it there by doing a string search.
Absolutely. So in addition, we just wanted to make sure we shared some other resources with you. Keeping up with memory, there are some great classes you can take. Here are some great people to follow on Twitter. And we actually created a workflow guide. If you use this bit.ly link, not only will you get a nice poster size workflow guide that shows all of the CLI and MemProc and has all the listings of the tools, the VeriCrypt plugin, etc. There, but we also have the deck there so you can reference these slides, as well as print out that poster and bend it to your will and create your own workflows. And with that, we really thank you.
I think we actually made time.
You did. Thank you both. And you know what? I have a great question that just came in that I want to ask you. Is there a good resource to practice on fake scenarios for those who cannot afford training?
There, so I think we're both going to name different resources. So I will. I cannot remember this gentleman's name off the top of my head, but there is an amazing student, forensic student in India, who created, and I feel so bad that I can't remember his name, but I will tweet out his memory labs. He created all of these memory labs this year that are fantastic, and they are wonderful images to go ahead and practice and test on. And also we did include memory images in the CTFs for Magnet at the Magnet Virtual Summit, and I'm happy to share those links out too. So I'll make sure I tweet those out.
Great, thank you both. And I went through track 2 and your channel and tried to pin questions, more so in track 2 so that you don't miss them.
Okay,
so
great.
Just go and take a look when you can. Thank you both for doing this. Fantastic talk as always. For those of you listening, please don't forget about your evaluations. I saw the link was posted, and also Jess is nominated for some Forensic Forecast Awards, and I posted that in the channel as well. So if you have not voted, you have until tomorrow. So
thank you, Heather. Heather's also nominated for several awards. So
thank you, Jess. Thank you.
Thank you, everyone. Have a great day.